Hello, everyone. Welcome back to Math. Today we begin Chapter 13, Probability. We're working on the Do You Remember today. But before we do that, I'd like to just introduce you to the goals that we are going to be working on for Chapter 13. Here are the 5 goals at the bottom of the screen. You'll be able to conduct probability experiments. So actually doing whatever it is that you have to run using the number cubes or spinners or heads and tails on a coin. You're going to be working towards doing the experiment and doing many trials for that experiment. Describe probabilities using fractions and percents. We're building on what you've learned in previous chapters and years with fractions and percents. You can write the probabilities in both of these forms. Next point, solve probability problems experimentally and using tree diagrams. Tree diagrams you've used before as well. However, we're going to be looking at the experimental aspect of it. What happens when you conduct the actual trials? Next one, relate possible outcomes to theoretical probability. You're going to be looking at the experimental probability and the theoretical probability. If you don't know what those mean yet, that's okay, because we are going to be talking about that extensively. And that's our last point right down there, comparing theoretical and the experimental. To begin, this is pure review. There's nothing new that you've learned here. So we're going to be reviewing things you've already learned previously. Number 1, based on Tyler's data, what is the probability for each? Rolling a 6, A, and B, rolling an even number. For A, we can simply count the number of sixes we have here, and we need information for that as well. We know that there are 18 total outcomes. If we counted these all, there would be 18 of them. And because there are 18, if we write it as a fraction, our fraction is going to have a denominator of 18, which we have right here. You can see from our fraction, our denominator is 18. And because there are 3 sixes, one here, and one here, we have 3 outcomes that are sixes out of a total of 18. We can bring that to its lowest terms, which is 1 over 6, or 1/6. That makes them equivalent. We can show it in either way. We can also convert this to a percentage if we want, but for this question, it's enough to have a fraction. Part B, rolling an even number. There are still 18 total outcomes, and our even numbers here, we can count 8 even numbers, 2, 4, 0, 2, 4, 6, or 8. We can look at those even numbers, and there are 8 of them. And because there are 8 of them out of a total of 18, we have 8/18, and that's equivalent to 4 over 9 or 4/9. Number 2, mark each probability from question 1 on the number line. We're going to start off with B. So B right here, it's 8 over 18 or 4 over 9. This requires a little bit of using the number lines that you learned in the previous chapter. So here's 0, and here's 1, or 100%, or 1 whole. You could look at this as 1 over 1, for example. If we cut this up into 9 pieces, imagine 9 pieces. So approximately 1, 2, 3, 4, 5, 6, 7, 8, 9. And our 9/9 would be where the 1 is. Our 4/9 would be just to the left of this equally likely line right in the middle. So our B would be right about there. That's approximately where the B would be placed because it's a little bit less than half. We're doing the same thing now for A, which is 1 over 6. For 1 over 6, we could look at this. This is a little bit easier because we do have the sixths here, and this exactly half line here would be 1/2 or 3 of the sixths. So 3 of the 6th would be right in the middle where it says equally likely. So if we take this and we bring the whole thing down and mark it out of sixths, then we could label the A 1/6 as only one of those 6 pieces across, which would bring us to about there. So this is about 1/6 of the whole way, probably even a little bit to the right. It's about right there. And that would be where our less probable aspects would be. Let's go to the next page now. In the next page, the spinner is spun twice. Based on the results, which of the 2 listed events is more likely? Spinning 2 5s or spinning 2 10s? B, spinning 2 5s or spinning 1 5 and 1 non-5. We're going to take a look at these now. So for spinning 2 5s, we can do that twice. And for spinning 2 10s, that comes up 0 times. And you get this simply by counting. So 2 5s come up here in the top right and then down on the bottom. So we have 2 5s there, and 2 10s does not come up at all. So clearly the 2 5s would be more likely to come up. The next one, B, spinning 2 5s or spinning 1 5 and 1 non-5. We have 2 5s once again coming up twice, and 1 5 and 1 non-5 comes up 8 times. The 10 and the 5, for example, is a 5 and a non-5. So a 5 and a non-5 is more likely to be spun. Number 4, Julia is picking 2 cubes from this bag. She pulls one out, puts it back, and pulls out another one. One outcome is blue, red. List all the possible outcomes. For this, we're going to use an organized list. One very important component here is that she is replacing the cube she pulled out first. It's a completely different question if she does not replace the cube, but for this one, she is replacing the cube. Using an organized list, let's start off with having all of the blue ones first. So if I pull out a blue one first, I pull out a B, which I'm using for blue, pull out a blue and a blue. So this BB means blue, blue. This BR means first I pulled out a blue, then I pulled out a red. The BY means first I pulled out a blue, then I pulled out a yellow. So this right here, this is all the different ways we can have an outcome that starts with a blue. There's no other outcome that can be possible. There are no more. So now our next option would be, let's see, all of the outcomes that start with red. So the first one, red, red. The next one would be red followed by a blue. The next one, red followed by a yellow. There are no other outcomes we can have there. And the last would be all the outcomes that start with a yellow. So yellow, 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 blue, and yellow, red. So using these conditions, there are only 8 outcomes that can happen with these 9 outcomes with these 3 cubes. By making an organized list, we're able to make sure we don't leave any out. We didn't make them random. We made them specifically with an organized list. And number 5, Sydney rolled a die 10 times. Based on her data, she listed the probability of rolling a 5 to be 3 over 10 and the probability of rolling a 1 to be 1 over 10. Record one possibility for what her 10 rolls might be. We immediately know how many 5s and 1s she pulled out of her 10 pulls. We know for sure she did it 10 times. We're told here with the 10 times, but we're also told with the denominator. The denominator gives us the total number of times she pulled out a number. So the total number of times she did this. So we know there are 10 numbers here, and 3 of them are 5s. We also know one of them is a 1. And I've written them down right here. The other 6 numbers can be any other numbers from her die, except for a 5, and a 1. So she can have 6 more 2s, or 6 more 3s, or 6 more 4s, or 6 more 6s, or a combination of that. I'm going to make up some numbers here. So 2, 3, 3, 4, 6, 6. So I have all the numbers here. Now that I have 10, I can count 3 of them are 5s. One of them is a 1. Of course, there are numerous other answers here with a standard 6-sided number cube. The next question, the last question here, number 6, record each fraction as a percent. The 1 over 10, we can call it, as you can see here, 1 over 10, we can say 1/10, which I've written as 1/10, the 1 in the tenths column. And because I've written it as 0.1, we can say that as 10%, which we learned in the previous chapter. 6b, 1 over 4, I can call it 1/4. 1/4 I've written here as 0.25. That's 2/10, 5/100ths, and there's our 25%. And our 3 over 10 can be written as 3/10 or 30%, and there's our 0.3. And that's a quick review from the previous chapters that we're going to be using for chapter 13. Thanks, everyone. Have a good day.